Okay, so we have been talking about B-spline curves, right? So we'll continue on it. Let's have a bit of a recapitulation of some aspects which we saw last time. So what we observed in the case of B-splines, that B-splines enables for us to define for each control point an associated unique basis function, right. So in turn what happens is that the influence, the way a point on the control polygon affects the shape of the curve, it actually is in a range of the parameter values, right. It is not the entire range of the parameter values, but it is a sub range of the parameter value, and in turn we get the local control, which is not the case in the case of Bezier curves, right. So, and also we observed that these B-splines help us decoupling the order of the curve or the degree of the curve and the number of control points you specify for the B-spline polygon, right. Okay. We also so the functions, the polynomial spline function which is used as a basis for B-splines basically defined as these nik's, where k is the order of the curve. So, therefore, it ranges from 2 to n plus 1, where n plus 1 is the number of control points you specify, right. So, the maximum order of the curve which you can obtain is n plus 1, and the parameter t ranges from some t minimum to t maximum, right, and these BIs are nothing but the control points. So, this is a very standard way of defining the parametric curves as some sort of a blending of the geometric information specified through the control points, right. And if we see how these nik's are computed, so they are computed in a recursive manner, where the base case is for ni ones, which is nothing but a some sort of a step function defined as 1 or 0. So, it is 1 when the parameter t is in the not values xi to xi plus 1. So, there is also a notion of not vector, which are in some way are the junction points for the parameter domain for the curves which is defined, right. So, xi and xi plus 1 are nothing but the pair of knots, right. And then the nik is just defined as a recursive in a recursive way, using the nik minus 1s and ni plus 1 and k minus 1, right. So, these are some combination of these, and the xi, as I mentioned, they are the not values, and there is a property to these not values that they are monotonically increasing, right. And we in particular observed that there could be number of ways in which we can define or give the x values or the not vector x. So, they could be uniform x or uniform not vector or periodic not vector. Periodic because the nik's which are computed using these knots turn out to be periodic in nature, right. Or it could be open uniform. So, there we have the multiplicity of the knots at the two ends, right. So, the knot is repeated k times at